Hello everyone, welcome to CactusCon. This is my first time here. I'm really excited to be here in person. Thank you for joining me for this session of some API security. API is great, it's nice, we all like it, we all use it, but it has its pitfalls, and we're going to discuss that today. So let's start with a quiz. What do all these logos have in common? I'm sure there are several answers, but the one that I'm aiming at is that all of those had some sort of breach or vulnerability exposed around APIs, and this is only in the last year, maybe even less. So probably next year, if I'm giving the same lecture, I will need smaller logos. Who am I? My name is Erez. I'm the head of security research at Checkmarx. I'm fascinated by information security and application security in general. Application security started as something that is very limited to code, but these days application security is much wider than that. We move from the code you write to the code you use to dependencies, open source, APIs, containers, everything that is cloud, and even supply chains. So we need to move forward, and this is, to me, it's fascinating. I'm a software developer. Originally, but I realized that I'm better at breaking things than actually building them, so I did this transition. I'm a strong believer in spreading security awareness. This is one of the reasons I'm here. I lead OWASP projects, including the API security project that we're going to talk in depth about during this talk. And I'm also the founder of the AppSec's village in DEF CON. On top of all that, I have a superpower, and this superpower is the fact that I see a lot of mistakes out there. Through the projects and through our customers, I see many, many mistakes. And the mistakes giving us the secret power of predicting the future. Because the technology moves forward, we know that security sometimes stay behind, and then we start to see the mistakes and the problems accumulate. And we're definitely in a point where a lot of problems and lack of information comes around API and API security. So what is an API? I'm not going to read you the entire Wikipedia paragraph about that, but basically API, we all know that, it's an interface or communication protocol between a client and a server. A client as a server can be basically anything, and if we look at the simple graphic here in the bottom of the slide, we can see that the APIs are the glue or the connections or the pipes between different components. So we have component 1 talking to component 2 and component 4 talking to component 1. And this talking is done by APIs. So what is API security? What are we going to talk about? To understand what API security is, I want to discuss the question, what uses APIs? So basically everything, really. Microservices and mobile and IoT cannot really survive without talking to some sort of server. Every B2B these days is using an extensive list of APIs. Everything that is serverless, everything that is cloud, and also the very popular these days single-page applications. Really everything uses APIs, and we really love APIs. APIs are great, we love them, they're very useful, and every modern application basically uses them. So when I talk about API security, what I'm actually saying is the security of API-based apps, and actually this is the modern application security. This is where we are now. There is no application security without looking at API security. This is not something we can do anymore. We cannot ignore that part of security. So I mentioned modern. So let's mention the differences between modern and traditional applications. So let's start with what is similar. In traditional applications and in modern applications, we have a user contacting some sort of client. In the past, it used to be only a web browser. These days it can be IoT, mobile, smart toaster, bot, whatever. we don't really care, and the user doesn't really care how do you interpret that. All the user want is the same in both ways, to get back the information they are looking for or to do the activity they're expecting. This is similar. Another similarity is the server that is talking to a database. In the past, we had an actual server, maybe even a server room, talking to a database. These days, the server can be an aggregation of microservices or whatever. Also, the database hopefully is no longer the dreaded SQL server, but some sort of Elastic or other NoSQL. But again, the similarity is the same. The result is the same. You get some sort of information from the database to the server. And here starts the interesting part, the difference. In traditional application, the client would send a GET request. The server would do the logic part, the understanding of what's happening, and reply with a completely rendered HTML page. These days, it's not the same anymore. Currently, our client sends a series of API GET requests and gets back raw answers with parameters and information. The logic part happens on the client. And this is an interesting part of the difference. So we see less abstraction layers also, and we see that the client and server, and also database many times, speak the same JSON language. We see that JSON is what connects everything. Obviously, we can use something else, but this is the most popular one. So the differences we see are that the server is used more as a proxy for data. The rendering component is the client, not the server. And the user state is usually maintained and monitored by the client. These are all interesting things that we will touch a bit later. Also, we need to remember that clients consume raw data. This is the data that comes directly from the server. More parameters are sent in each HTTP request. We see different parameters, object IDs and values and filters, and everything is just sent raw on sometimes JSON, sometimes something else, but just flying through the air. And the last point is that APIs expose the underlying implementation of the application, and we will discuss that also. So what makes APIs so vulnerable? Why are we talking specifically about the vulnerabilities of APIs? First of all, there's a lot of them. Every endpoint of an API is an entrance point. Everything makes endpoints attack surface bigger. And if in the past we had users that they have just one doorway in component A here, for example, and they had to do some sort of authentication or authorization and then move to component B, C, and to the data or assets. Now we have maybe malicious users that are not going through the right order. Maybe they find the component H that talks directly to B. Maybe they can talk directly to B or to C. They don't necessarily have to go through the same process that happened in the past. Another reason that APIs are vulnerable. Clients consume raw data, and we discussed that. More parameters are sent, and you don't always know where you sent your stuff to. To be more exact, you know where you send it to, you don't know what happened to that afterwards. So, for example, if we see here that component 1, 2, and 4 are part of some sort of safe, let's call it perimeter. Component 1 sends some information to component 2, but what they don't know is that component 2 will then send it to component 3. The other way is also relevant. Component 1 is getting component 2's information and believes it's secure and safe, but what they don't know is that component 2 got it from component 3, actually. So this is a problem. And the last thing that makes APIs vulnerable is the flexibility of CI/CD. Yeah, the flexibility is great, it's amazing. It's effortless, but it takes just a few clicks to spin up new APIs. You see hosts and completely new sets of APIs with just a click of a button. And it's almost too easy, really. We see that all the time. People are just waking up in the morning deciding to have a completely new set of APIs. In the past, you had to work through some problems. Now in 10 minutes you can have that running and working for you or against you. The rate of updates and changes in APIs, it may be too fast to handle. And we see that APIs become hard to track. We see more and more shadow or orphan, it's the same thing, APIs out there. And we find a lot of exposed APIs that no one really remembers what they are, who actually spun them up. This is a problem. So let's stop for a second. I'm not trying to depress everyone. This is not all bad news. In general, we see that traditional vulnerabilities are becoming less common in API-based applications. We see less SQL injections due to increasing use of frameworks or ORMs, so this is becoming less and less of a problem. I'm not saying it's not a problem, but it's less common. CSRF, again, we see other ways of doing that instead of cookies, so due to authorization headers instead of cookies, this is getting better. Path manipulations, cloud-based storage is trying to solve that. There is path manipulation in cloud as well. We see that and we see abuse of that, but again, this is less common and less severe. And in general, many other classic security issues are being solved by software as a service. So how do we bridge the gap? How do we bridge the gap between the security knowledge that we had as, let's call it, traditional application security staff or engineers, and the new modern world ruled by APIs that we have around us? So usually what I do when I have some missing information, I go to OWASP. If any of you don't know OWASP, this is a good time to write it down and look it up later. Consider it your mandatory homework. OWASP is a great organization that is working very, very hard on making information accessible to everyone. The closest thing I could see is the OWASP Top 10. OWASP Top 10 is something that many people know. The only thing people know about OWASP has many other projects as well. So we took a look at that. This is the one from 2017 when we had a discussion. So there is now a new one, but basically we took a look and said, no, this does not fit the modern or the API-based applications. So we decided to actually create a new project, and by we I mean myself and Inon Shkedi. He now works at Traceable, and we decided to bridge the gap with this new security project. And this is where we created the OWASP API Security Top 10, and I'm going to explain to you each of every category with some examples so we can understand a little bit how does the ecosystem of API security looks like. So let's start with the one we just shamelessly stole from the OWASP Top 10. Injection and insufficient logging and monitoring. These are API 8 and 10. Many asked us why we dropped it from A1 to A8 in our session, in our model of API security. First of all, again, this was 2017. OWASP since then dropped it to A3 from the top 10 itself. But this is something that I already mentioned. Injection is number one because of SQL injections. They are less common because of ORMs and increasing use of NoSQL. And again, I want to say that NoSQL injections are a thing, but usually not as common or severe. So we decided we definitely want to keep it in the top 10, but drop it down to number 8. Regarding insufficient logging and monitoring, there is nothing special I can say regarding from the API perspective. Really, attackers rely on lack of monitoring and timely response to achieve their goals. So this is something that every application must have some sort of logging and monitoring. Again, not related to APIs whatsoever. This brings us to the most interesting and problematic category, which is access control. Access control is by far the biggest issue in API security. And the issue is so big that it actually got its own slide. Please remember that. Access control is API security's biggest challenge. And let me show you why. 3 of the top 5 out of the top 10 are actually about access control. We can see 2 items here, API 1 and API 5, about broken authorization, and 1 about broken authentication. Let's start going one by one. So we will start with broken authentication here. Broken authentication can happen because of 2 different similar yet different reasons. One of them is lack of protection. The other one is misimplementation of that protection. So, for example, here is a set of different API endpoints. We can see login and login from mobile, or forgot password. Also, we can see an API endpoint to update your location or edit a photo. And we have some general protection for that entire set of APIs. But what we need to remember that everything that is around login must have its own extra protection. And by extra protection, I mean CAPTCHA or 2FA or account lockout mechanism. Basically anything that will avoid brute force or credential stuffing or password spraying must be in there, because if not, you will have broken authentication. The misimplementation part is sometimes harder to catch, because you do have a security mechanism, but sometimes you misimplement it. For example, we see a lot of engineers using JWT for their security, but then JWT support an algorithm that it called none. Basically, you're using JWT without any encryption. Sometimes there is no validation of authentication provider. So we see applications that are checking that they got an authenticated user, but they did not check where this authentication came from. And sometimes we see passwords stored without salts, which is, yes, you do store a password and you do have a password mechanism, but it's weak. So many different different ways to shoot your own foot. But this is something that is very common. The reason it's common is that authentication endpoints are exposed to anyone by design. We want them to be exposed to user. This is the purpose of them. And we know that software and security engineers have misconceptions. We see all the time that API keys are used for authentication, and people are confusing authorization and authentication. This is a problem. Not to mention the multiple ways you can authenticate these days. Obviously, the authentication on an IoT device would not be the same as authentication on mobile. It would definitely be different than some legacy web, and God forbid the infamous deep links with credentials that goes directly into assets of applications. Moving on to authorization. So we have a broken object level authorization. It also got the nickname BOLA. When your object level authorization is okay, what you will see is a user is asking for a specific asset, their asset, and then they get a response, yeah, okay, sure, that's yours. If they ask for an asset of another user, they will get, no, that's not yours, you are not authorized to get that. If it's not working like that, it's very simple. You have a situation of broken object level authorization. Why is that common? You remember that part. The attack surface is much wider. We can try and get these assets from anywhere without being authorized. Also, there is no security solution that exists that solves the problem. There's no silver bullet. It needs to be baked into the logic of the creation of the application. And this is always something that is, unless addressed from the beginning, might be a problem. Usually at that point, some people are moving uncomfortably in their seats and saying, why are you calling it BOLA and not IDOL? Why did you have to change the name? So I will explain. We believe that it's not really accurate to use IDOL, and the reason is that the D in IDOL means direct. IDOL is insecure direct object reference. We don't think the problem is the direct part, the directness. So either implies that the object reference should be indirect, like a salted hash map or random string for every ID. We don't think this should be the mechanism. We believe that the problem is not the object reference, but it is the lack of authorization. Theoretically, there is a situation where every user will try to access any object. They need to go through some sort of authorization and not just hope that they will not guess the name of a specific asset. Also, what would happen if you ask your developer to implement indirect mechanism in every place that receives ID? I have news for you. It will not happen. Hopefully not that violent, but it will not happen. So that was broken object level authorization. Let's go to broken function level authorization. While broken object level authorization was what kind of object or asset you are allowed to touch or access, broken function level authorization is talking about what you are allowed to do with that. So in a way, when we look at different APIs, they have different levels of access. We can see a public API here. For example, both an admin and a regular user can get a profile of a user. This is something that is public and it's okay, and they're both supposed to get an okay with that. But when an admin goes to the admin API and asks to delete a user, now delete is a different function. It's not like getting it. They should get an okay, but when a regular user uses the delete function, they're supposed to be told that they're not authorized to do that. If this mechanism does not work, what you have is broken function level authorization, or BFLA in short, if you want. Why is it so common in APIs? So function level authorization can be implemented in different ways. It can be implemented in code, configuration, API gateways, infrastructure, really. Every place in the chain can have that implementation. We all know what happens when many people are in charge of one specific thing. Who is doing that in the end? No one. And that happens a lot, where everyone thinks that someone else will make sure that this is done, but eventually it does not. Also, it's easier to detect an exploit when we're talking about APIs. The endpoints are predictable, and I want to show you how predictable they are. So in the traditional days, let's call it, to get a user's profile, you would use some sort of GET request through some sort of user's view with a user ID. The deletion of a user would probably be through some sort of cumbersome admin panel or user management page. Everyone had their own way of doing that, and this is how it looked like. These days, with APIs, this is how it looks like. You want to get the profile of a user, or you want to delete it, this is really the same. You just change the function. So in the past, harder to predict, and now very, very easy to predict. It's so easy that it's completely automatic these days. When you're having penetration tools, they're just switching the function and you get everything. Let's see how it looks like in real life, access control in real life. So this is something from several months ago. My team in Checkmarks, we found API vulnerabilities disclosed by researchers. This is us. You can see you can find it online also. We basically managed to take over Coursera API because of access control issues and to hijack the accounts. When I say hijack an account or get access to assets, it can be files or private things, but it can be everything or anything. For example, this one, another thing that our group did more than a year ago. We found an API issue with a smart vacuum cleaner that also had a camera on the smart vacuum cleaner. Basically, the assets that we managed to get there are that. We managed to get video streams from the camera of the vacuum cleaner and location, basically everything, the name and address of the users. You need to remember, access control is everything. If you don't have access control, this is pretty much game over for your application. Moving on, you still have the strength needed for a few more. Okay, moving on to excess data. Excess data has two different categories in it: excessive data exposure and mass assignment. These are actually one and the opposite they're the opposite of each other, and let's see how. So this is Bob. Bob is using the super safe app, and the reason he's using it is because he's sure that his information is safe, and the users can only see his name, role, and hobby. And this is the only thing that Bob wants to share, and he believes that this is the situation. But when someone is actually looking at what happens behind the scenes, there's the mobile phone run by API. You see the mobile phone sends a GET to get Bob's profile, and they get this JSON. And in the JSON, you can see that not only the picture and the name and the role and the hobbies are here, but also the address. So the fact that you don't see it on the application does not mean it was not sent to the application. And what we see is many applications that are filtering sensitive data on the client, and this is always a bad idea. Always. There is zero reasons to use that. Why is it so common? Again, so REST standards encourage developers to implement APIs in a generic way. We see all the time generic functions like toJSON. Yeah, just take the entire user object, make toJSON, and send it somewhere. This is very, very easy. toJSON, toString, all these functions. Sometimes we do that without thinking who is the consumer of that specific information, or who is the consumer in the next step. If we send it to someone that's supposed to get it, that's fine, but maybe the next step is not fine anymore. This is something that is very, very hard to follow. And this is Bob's case in real life. How many here are using 3Fun? Okay, I don't expect anyone to admit. If you don't know what 3Fun is, it's basically a matchmaking Tinder-style application for people who believe that 2 is not enough. This is probably the best way I can say that. And a researcher called Alex Lomas from Pentest Partners, it's an old one, but I like to show that every time. So he found exactly that. He saw that information that is coming from the servers to the application does not only have the allowed photos and the name and all the public information, but also sensitive information like phone numbers, exact location, pictures that are not public, etc. So this is exactly how it looks like in real life. Obviously, Alex Lomas did the responsible thing and mapped it around the White House. That made a lot of noise back then. But yeah, this is exactly how it looks like when you filter things on the client side and believe that things are safe. API 6 is the other way around, is the mass assignment when you get information that is not completely vetted. So modern frameworks encourage developers to use mass assignment functions, very, very similar to the way they encourage us to spill and leak our information. They also encourage us to get them. For example, this is how simple it is to create a new user in Node.js or Rail. You just take the entire body from the request, throw it into a new object, and you have a user. Congratulations. The problem is that this thing might contain sensitive parameters that a user should not have access to. An example, again by Bob, may look like that. So if Bob sends a post request for a new user where his username is Bob and the password is 123456, this is legit, this is okay. But what if Bob is not using the client but using some other tool to send the post, and it has not only his username and password, maybe he can try something else. How about adding a role admin, for example? That might work if there is, well, it will work if there is no mechanism checking what you're getting. If you're using the code on the left, Bob is now an admin on your system. and we see that much more than we want to. So this is the access data part. The last part, the last category is the category that we did not find a name for, so we called it DevOps or DevSecOps or general things. Lack of resources and rate limiting, security misconfigurations, and improper assets management. Lack of resources and rate limiting, I think it's quite self-explanatory. When a resource, and it can be anything, really anything that we're using, files and memory and CPU, access to database, whatever. When it is exposed to the web, there should be a defined use limit. If it's a request, then a numbered frequency, and of course, in files, it's the size, or string, it's the length of them. But we must remember that. And not only because of the reason of denial of service. Denial of service is something that we all talk about with rate limiting, but we should not forget, again, the access control, the brute force attacks. Brute force attacks, if there is no lack of resources, there's no rate limiting, brute force can happen very easily with credential stuffing and password spraying and whatever. Security misconfigurations. This is where things got wild and we actually cheated. We just took a big bucket of bad things and put it under one security misconfiguration. The funny part is that the OWASP top 10, the original one, not the API one, actually added misconfiguration also as a category. So we really like our bucket of bad things now. It includes everything. It includes weak encryption. It includes unnecessary exposed HTTP methods. It includes everything that should be false but is true, or should be true but is false, CSRF protections, detailed errors, course, you name it. There are so many things like that, and checklists out there that we need to keep an eye on. These are very, very relevant in our modern API environment. And the last one is my favorite and least favorite together. I don't know how it happened, but this is improper assets management. Improper assets management is a housekeeping issue. Sometimes it's not a vulnerability by itself, but most of the times, if you have an improper asset management, this is the source of all evil in your API security. It can be one of two different but similar, again, housekeeping issues, either lack of documentation. This is an example from real life. Just the name of the target is different. We found a payment API of a company. Everyone could easily say what does version 2 download transactions as PDF is. They have very good documentation of that. Another one was version 2 transfer money. And then we found version 0 legacy B2B export all users. No one knew what it is. No one knew what it's about. Export from where to whom? No idea. This is a bad thing to have open in your system. Another side is the exposed risky APIs, when you not only forget them, but you forget to cover them. One can be the reason of the other. So this is another true target. Again, not the right name. They were very happy because they used API Gateway. It worked very, very well for their payments API and for their mobile API, but it worked well only on those they remembered to cover, because someone forgot somewhere along the way to cover beta API. And this entire set of APIs were totally exposed. You can imagine also that if a beta API is exposed, there are some shortcuts there that should definitely not exist on APIs and definitely not open to the public. We really see a lot of those. This is common because of the simplicity of CI/CD. And again, I try and explain to people that there is such a thing as too fast. I mean, sometimes too fast is not the best way. Also, developers are focused on delivering and not documenting. I believe that documentation was the thing I hated most in my job as a developer. Developers like to deliver, they like to build, not to develop, not to document. And it shows. And really with cloud and deployment automation, it's so easy to spin up new APIs, and we have APIs hosts that have been forgotten, complete environments that have been forgotten, and this is something that you can know just by walking in an open space of a company of developers and hearing in the air someone yelling, "What the heck is a QA3 old AppCom?" or something like that, and we do hear that sometimes. If you do, it's a red flag. So that was the top 10. I hope it was not too much. I want to summarize some stuff for you to take home with you. So I hope I showed you that modern API-based apps are different than the traditional ones. I hope I managed to convince you that being different, they have their own security issues, and they should be treated as those. The attack surface is much wider. This is something we need to remember. We know that instinctively, but we need to remember it actively. Everything we add makes our attack surface wider. There is more data moving between components. We don't always have control on this data. We don't always know where it came from or what the purpose of it. This is something that we need to remember while we are writing our code. And access control is a real challenge. Don't forget that. Thank you. Questions? Yes, please.
Yeah, so your examples seem to be taken from REST, and I'm wondering what the top 10 ranking is equivalent for OData or SOAP.
Okay, so yeah, the reason that the examples are around REST is because this is the most popular one, and it was almost the only one when we wrote that top 10. We're actually starting to work on a new version. Hopefully it will include GraphQL and others. So you can expect that towards probably mid or towards the end of the year. The ideas are the same, but you are completely right. There are some changes that are relevant for different types of API technology. We have a running microphone.
So I've seen a lot of other APIs out there, like Swagger's a new one that I've started to see out there, to where people just pull down this, whole, API and line that into an application. Makes me nervous, right? Because all of a sudden we're starting to trust other libraries, other examples, other APIs. Are there some APIs that are good, more intrinsic, or is it literally just how it's used as an API? Like, should we just not be trusting some of these, kind of pre-built modules that we download from GitHub?
If someone that knows me will hear these questions one after the other, they will think I actually implanted them. Because another topic we're discussing now is not only the way that we treat APIs with our information, but also the way that we trust other APIs, exactly what you say. And I think that we need to make that extra step, this transition of, let's take a similarity from open source. Open source has a lot of dependencies, and again, it's great, it's good, amazing, we love it, it makes everything fast. Sounds like API, right? But then sometimes we have problems. Specific packages are problematic, and supply chain, etc. The same with API. Suddenly, you might find that a specific API you trusted is not as trusted as it's supposed to be. Or maybe it's even malicious, or maybe they just themselves did not care about security. So this is definitely another new front for the API top 10. This is definitely something we need to take care of, because the trust issue here is getting problematic. More questions? Okay, so if anyone still wants to chat, I'm here for the next couple of hours, just walking around.
Question from
questions online. Cool.
Is there a tool out there that we can find out those exposed APIs that are forgotten?
I think there are many different tools. I'm not going to name any specific ones. There are different tools that are trying to find automatically your APIs. I think that the best way is to do it not totally automatic, but do it in a way that is smart, in a way that you're looking things in areas that you may have forgotten them and things like that. Also, you can try to look at other tools like OWASP Zap, which is open source, and others. But there are tools out there.
That's it.
Okay. I'm not sure I really answered the last one or just dance around it, but okay.
Yeah, there's someone typing something potentially.
Someone typing.
That's what it says.
He's holding everyone hostages.
I guess I do have a follow-on question. If you were to design an API model or protocol with security as its front end, what would that look like? Or is that too abstract a question?
It's extremely broad. How do you design secure API? This is probably a topic for a book or a PhD. But I think that awareness is the main thing I need to push here, just to understand what might go wrong and understand the parts that are a bit squeaky and not completely secured, and keep, again, access control, keep it in mind from the get-go. And making sure that you document everything, that you have very clear protocols of spinning up a new API, very, very clear protocols of deprecating ones. If you don't use something, remove it. If you have a version that is not in use, remove it. That is that. Just awareness.
Thank you.
Okay, they never finish it up. So.
Okay. So thank you, everyone. I appreciate you coming here. And be safe. I have no problem making them available. So
Okay.
I'll talk to the guys in CactusCon and they'll be able to publish it probably.
Okay, yeah, I have to do an annual OWASP top 10 training for the developers.
You have to.
And as a security guy who knows very little about things like APIs, I know that they exist, I know what they do, but I don't know how to work with them.
This is exactly what the talk is all about.
So when they say, okay, you need to